Now we have some harder applications of the product rule with the functions here, because we're going to use the product rule, but we're also going to use the chain rule, because notice our brackets here are to a power. So we've got to take that into consideration. So if we're going to derive the first one here, so the 5 is going to stay out the front, and we're going to bring our 4 down, subtract 1 from the power, and then multiply by the derivative of 3x minus 2, which is 3. So there's that part's there, had the chain rule applied on it. And there's our second bracket. We haven't touched that. That just multiplies by the second. So that first part there is the derivative of the first bracket there. So applying the chain rule there. So then we have the first function. And we've kept the 5 in with the first function there. And then multiply by the derivative of the second, which is the 3 comes down. Subtract 1 from the power. The bracket stayed the same. Multiply by the derivative of the bracket, which would be 1 because the x derives to 1. So that's what it looks like. So we're quite happy at that point. But let's just clean it up. So we can get our numbers. 6 times 5, 4 times 5 times 3 gives us 60. And we'll have the 3x minus 2 all cubed, x plus 8 all cubed there. And 5 times 3 gives us a 15. And we can have our two brackets brought down there. So we can simplify the numbers. Don't expand the brackets. So we say don't expand the brackets at any stage. Oh, that'd be nasty. Because the powers are too high. There'd be too many terms. So the powers just would not make that very nice. What you could do if you want is to start to factorize, because they've got common terms. Like 15 would go into 60. We got common term of 3x minus 2 all cubed, and the x plus 8 all squared could be factorized out. That's if you want to. If you need to do it with applications later on, then that's able to be factorized. But that's all we would do. We won't try and expand it ever. So don't expand. So let's see it in question 2. We've got 4x plus 5 all cubed. Apply the chain rule. So you brought your 3 down. You've got the 1 from the power, and you've multiplied by the derivative of 4x plus 5. Kept your second bracket. Plus the first bracket times the derivative of 2x minus 7 all the power of 5. So apply the chain rule. 5 comes down, subtract 1 from the power, 2x minus 7 in the brackets, and then times the derivative of 2x minus 7, which is 2. And then clean your numbers up. 3 4s are 12, 2 5s are 10, and we keep our brackets there. So that's all we're doing with this one. Again, so derivative of 6 outside of x minus 6 power of 5. Well, there's that derivative there, times the 4x plus 3 power of 8, and we've kept the 6x, 6 outside of x minus 6 power of 5. Derivative of 4x plus 3 to the power of 8, bring your power down, subtract 1 from your power, times by the derivative of the bracket. We keep our bracket the same, clean our numbers up. So the same thing, you see the practice there. Derive the first times the second plus the first times the derivative of the second. And then collect all your terms there. So these ones, even though they look harder, and they are harder, they're not impossible. It's just applying those rules. Deriving the first times the second plus the first times the derivative of the second, and then collect your terms. So same thing again. Derive the first, leave the second, and then leave the first one there, and then derive the second one, and then multiply your numbers to give you whatever values are there. If you need to factorize out, but don't ever expand these ones. It just becomes way too hard, way too nasty, and you don't really want to have it do that, because it really won't help you to solve anything else in the question. It just will cause simple errors.